Hello guys, welcome to my electronic YouTube channel. So today I'm going to review this TENMARS TM-13E clamp meter. So here with me this multimeter. So you can see this is a very clean box. This is the block of this multimeter. Okay, there's no any other many mentions, any other things mentioned. The only thing is they show that this is the TM-13E brand. That model number is TM-13E name. So that's just in there. So anyway, so there's nothing in there. Very cheap box you can see. So now I'm open it now. So you can see this is very cheap box, nothing in there, but the multimeter is a very branded one. So that multimeter is from Taiwan, you know. TENMARS is very branded multimeter type. So anyway, so I will take this out. So that I have some sort of zipper bag. I hope this multimeter is inside. Okay, so what else? Aha, you have some sort of a notebook. What is this? Aha, I hope this one is a service manual. So yeah, service manual. So there's a contents available. So what are these features, specifications, the data specs, and description, how to use, caution, warning, likewise so many things are available. So I will be put any some sort of a PDF or something for scan this document with this link description. So anyway, so I will keep it that way. So now I'm going to open this nice, look very pretty, okay, very nice bag. So I will open it now. So what is in there? Haha! Look, it's so very cute. That TENMARS TME multimeter is available here. Okay, I will keep it here. And what else? Okay, some sort of testing leads available. What else? What is this? Oh, certificate of calibration. Oh, TENMARS Electronic Copyrighted Limited, Taiwan. So, are there any date or something? No, no date. Why? How will we take its calibrated or not? I don't anyway. So there's no mention in it in here. Okay, this some sort of a paper, just a paper. Okay. What else? Oh, what is this? Oh, yeah, don't eat. Do not eat. It's not for eat. It's silica gel. Okay, it's not enough for our specification. So I will remove this one also. Right now I remove this bag and come into here. Ta-ta! TENMARS TM-13E here, this multimeter. Ooh, wow, very nice plastic material, made in Taiwan. Yeah, I know. Okay, this is some sort of a very plastic. It's okay. This also some sort of a plastic, not a rubber or something. So what a perfect finish, huh? It's very tightly fit to our finger. My finger, it's tightly fit to my finger. This one also give us some sort of a pressure to without that some sort of a, it's a very perfect one. Okay, it's some sort of a tough, it not it's some sort of a tough. Okay, according to here, so I can see some sort of a laminated some metallic sheets are available with there. I don't think so you can see that one in this camera anyway. So likewise this side is also same plastic, nothing else. So there I have a three type of very soft button. These are very soft. Okay, and this is the selector. Actually I had to talk about that one also. You can see this display is a very cute, very perfect clear display. It's very perfect clear display. You can see that one very clear. if I take this matchstick meter also, it can be some sort of a not a clear display, but you can see also this one also some sort of a this and to this display, this one is very clear and very nice display, very crispy display actually. That's a word for that one. So anyway, I hope you can feel that buzzer beep also. So that's how the uh, this uh, this clamp meters like that. So if I take these wires out, the test probes, what is in here? Let's remove this one also. Oh, wow, wow, wow. Oh, it's so nice. Okay, let's remove this strap. Okay. How much long this one? I hope 1 meter. Yeah, 1 meter, something like that. They have some sort of a clip also, so I can remove that one also. Here also can remove that one. So, whether what is the brand? You good TENMARS TL10. Oh, TENMARS. It's also TENMARS product. That means this calibrated cables also match to the TENMARS multimeter. What the perfect thing! This cable's also made by TENMARS. Perfect, perfect, very perfect. So, oh, they have some sort of clips. Oh, ooh, ooh, ooh. That one is not very perfectly fit. This one, it's very loosey. Actually, it's very loosey. But according to this one, also it one has some sort of tough. But this one is not tough. Okay, let's look at that clips. And what is these? Ooh. Wow, what a perfect. Oh, shiny, no? Some sort of a shiny. Very good, very good, very good, very good prop is in there. The tip is also perfect. That not much hard to me. Very nice, very nice, perfect tips. I hope it's some sort of very good material. So it's not can be excited or something like that. But I hope it's very perfect. Right? Okay. This one also hits some, giving some very precious. So it's okay. So cables are according to the cables data. Yeah, they have some sort of a cable data. So let's look what is that in there. 18 WAG, no? Yeah, it's showing what is that, 80 centigrade, 18 AWG, 18 AWG, 2000 volt, Leo HUI likewise. Okay, 2 kilovolt, but this one is, I hope, they're showing as a 10 ampere cat to 1 kilovolt. Right, so that's how the multimeters. So now we had to test our equipment with sort of a experiment. So let's go to that one. Okay, now I'm going to measure the voltage of the AC. So here I'm choosing our 230 volt outlet. So this is my matchstick meter reading. You can see this one is strictly similar to this voltage also. I told you this multimeter is a true RMS multimeter. So I hope that values are most probably it's true RMS. So it's look like it's equal. So that's how the AC voltage measurement of this multimeter. So now I'm going to talk about the DC voltage measurement of this multimeter. So now I put into the DC measurement, and also I put this matchstick meter also to DC measurement. So let's take a look at that voltage. So today I'm going to use this 9 volt battery. So let's look at what happens. So the voltage is showing 8.87, very stable voltage, you can see. Because this is a DC battery voltage, so it's perfect. So within this matchstick meter, Yeah, it's also same voltage potential will show. So that's how the DC voltage measurement of this 10 mass multimeter. So now I'm going to talk about the resistor measurement of this multimeter. So first of all, I had to put that one to the resistance mode, so it's in here. So now it's look like this. Okay, so in here I told you this one has self calibrated also, so and we can also manually calibrate it also. So they have some sort of a case in both multimeters. Why? Because this cables has some internal resistance. So if we can neglect this one also, then we can take a very accurate resistance reading. So in here they given as a zero button, so we can also we can calibrate that one also. If I connected this one, you can see they have some sort of a resistance 0.1 or something, so I can automatically neglect that one also using this zero button. Now it will automatically go into zero. So likewise, it's very important to remove that internal cable resistance with these multimeters. So right, okay, now I'm going to measure the some sort of resistors. So I have this is 1% 10 ohms resistor, so I can show it to you. So 10 ohms 1% resistor, so I'm going to measure that one also. So first of all, I had to, it's now it's on manual mode, so I had to put it into the auto mode. It will very effective and it's very easy. So I press this range button some sort of time, it will automatically come into auto range. So it's okay now. So I take a 10 ohm resistor to out of this case, right? I hope you can see that one. So let's make the measurement. So yeah, it's showing 10 per 10 ohms very perfectly. It's very nice value. You can see it's again, yeah, it's 10 ohms, very 1% one. This one is showing perfectly. So then after we go to this is some sort of another resistor. It's showing as 68k. So but anyway, we can measure this one also very fast, applying this one. So it shows 71.25 likewise that one type of resistor. This one is not accurate one, so very not as high voltage resistance. So anyway, now I have another one with this one here, 5.6k resistor. Let's measure this one also. So okay, so it's showing 5.58, very fast reading. You can see it's very fast reading. So that is very effective actually. 5.58, very near to close to the 5.6k. So now I have some sort of a high voltage resistor with me. So let's look at that one. Here I have 3.3 meg ohm resistor. What I want to show you, you can see this one also measurement is it's take some time to reach the value. So if I put this one with this, uh, first of all I had to take it out 8. Okay, then right, so if I connect it like this, so it takes some sort of a time to measure the value. So yeah, it's coming is 3.3 near to the 3.3 meg ohms, some sort of again half digit values also available in there. Okay, it's perfect. It's take time, but anyway it's showing the value some sort of a time. It's showing the value what our desired value. So likewise, that is the one. But we, if we go to the measure the with this mashtech meter, it's not auto range multimeter, you can see. So if I want to measure 3.3 ohm with this one, so what happened with this one? So it's also take it to higher value, then it will come into likewise same value also we can see also this one mistake also. So that's how the measurement of these resistors of this 10-mars TM-13E resistor multimeter, sorry. Okay, now I'm have to measure the currents. So first of all, I'm going to talk about the AC current measurement with this one. Okay, now I'm going to talk about how to measure the AC current of this using this clamp multimeter. So here, this is my multimeter. So uh, I put to AC measurement. You can see there's no want to again zero this value because it's near to zero. This is the some sort of a noise. It can be in here. So right, so I'm going to measure the current. So now I'm using 230 volt with this 40 watt filament bulb, and now I connected that one. So according to my matchstick meter, you can see the current is now is 170 milliamperes. So anyway, let's make the measurement of using this clamp meter also. So I put this one into here. Here you can see some sort of a thing in here. It's showing 0.12, that means 120 milliamperes, but in here showing 170 milliamperes. So actually they have some sort of a difference. I don't know what happened in there. Sometimes this is the actual true RMS value, this is not a true RMS value. So anyway, so it's showing like this. I don't know why what happened in here. The same thing is happening if I movement of this wire with any for things here. It's showing like that. So that's how the AC current measurement anyway. So I can easily remove and I can take the same value also. Okay, now I'm going to measure the DC current with this multimeter. So now I'm using a DC power supply with this type of fan. You can see this one is the 12 volt or 1 ampere, some sort of a very high power fan actually. So what I use in here behind this one because it can be fly. So anyway, so I had to put my clamp meter to DC range. So I put this one first. Then you can see they have some sort of level that we call as we have to null that one also. There's effect of the some other another magnetic field of our in our environment. So anyway, we have to neglect that, we have to null that one. So no need to think about much. They have some sort of a button, we call that one as 0. So we had to press 1, then automatically it can be 0. So okay, now I'm going to measure the current. So I put this clamp meter to this wire, so it's connected to like this. Okay, okay, now I'm plugged that my one. Okay, so you can compare that current values, uh, what are the happens with that one. So it's more near to that one also. So if I take this one into your middle point, you can see the current value will be way big also 0. It has some sort of error, so if you can also neglect that one also. Okay, same value potential also is not much accurate. You can see that one, it's not much accurate. It's some sort of accurate only. I can see in there what happened with this one. So something else of current, I don't know what happening there. Anyway, it's look like in here. So again feel same thing, I hope. If I put manual range, so it's showing like that. It's not showing much too accurate comparing with that one. we can't zero with that one also. So uh, let's try to make it games not zero. Why was that? Okay, now I again put that one. It's showing like that one also. I don't hope it's working for the positive terminals also. It's showing like that, some sort of accuracy. uh, Likewise it's showing like that. So that is the how the measurement of this one. You can see they also have some sort of level. I hope that is the case is some sort of a different of the our this actual value. You know, this one, these multimeters are capturing that current using some sort of a resistor. That means some sort of a resistor is equal to v equal to ir. Then they can calculate what is the desired constant resistance divided by that difference of the differential voltage. Then you can take the current. That's how this multimeters work. But this one is working for using this magnetic hall effect features. So uh, I don't know it's whether it's very perfect, but anyway, it's as you can see, it's as not going to zero. That's the case. I hope that different of that one. So anyway, this multimeter is very perfect. You can see it's very perfect. So anyway, now I'm going to uh, again take apart and look out the circuit how it's look like.